Welcome to Maths Club. Maths Club. There ain't no party like a Maths Club party. Okay, so it's not Maths Club. It's just some lessons, and we're today going to be talking about drawing a quadratic, plotting quadratic graphs, and this is aimed at secondary students through from year 7 all the way up to year 11s, even resit students in year 12. Anyone who needs to make sure they can master this. Watch, learn, do. Practice. In the description below, you will, or to the right, I don't know where the description is nowadays, you will find a link to some worksheets or exam questions to do to practice the skill. We need to learn the skill first. So without further ado, let's get cracking. So, what is a quadratic graph? Quadratic graphs look like this. The little curve. They basically are equations with x squared in them, and we're going to go through all sorts of different things about them, and hopefully everyone who's here with me today, Alex, Arian, and Alicia, and Nina, and Sophie, and Harry, and all the rest of you will get some learning taking place and find out what's going on. So I'm going to head over straight away to my board where I've prepared the lesson for us today. So we have got 6 different equations. I'm going to talk to you about how to do it. I'm also going to try and show you 2 different methods. There's a method I prefer. You are allowed a calculator for today's lesson. So if you have one accessible, this is a calculator lesson. You would be allowed a calculator normally. I don't know if there's a calculator. It's more like a TV remote. This is a TV remote lesson. You're allowed a TV remote while doing this lesson. So what is a quadratic graph? Well, on Monday we talked about straight line graphs. You will notice these all have something in common. X squared, x squared, x squared, x squared, x squared, and x squared. That makes them quadratic graphs. Or quadratic equations, if actually. We have to make them into quadratic graphs. These are quadratic equations. If they had an x cubed, they would stop being quadratic equations, they would start being cubic equations. So it's because the highest power of x is x squared. Now, if I magically make that yellow disappear, we are going to start here, and then we're going to progress through slightly harder, slightly harder, slightly harder, and I'm going to make sure you understand what's going on. For the first one, it's important to realise, because of the nature of it being a curve, not a straight line, we do need our table of values, and we always draw a table of values. Our table of values will be x, y, minus 3, minus 2, minus 1, 0, 1, 2, 3. Much bigger than the one for straight lines. But because what we're going to, if you remember from my Monday lesson, we've always got, in these equations, x is the input, y is the output. So we're going to put numbers into x and see what comes out the other side. So, for that, we need to remember one fact. There is no such thing as a negative square number. When you square a negative number, minus 3 times minus 3 makes plus 9. Minus 9, 3 times minus 3 becomes plus 9. There was no such thing as a negative square number. So when we're doing these, we're going to get positives out of the negative numbers when we square. Now, I think there's 2 ways to do it, but for the first one, there's only really one way to do it because it's just x squared. There's nothing extra to do. I'm going to show you both, but I'm also going to talk you through what I think is my preference. So, the first one says y is x squared. So, let's have a look. Minus 3 squared is 9. Minus 2 squared is 4. Minus 1 squared is 1. 0, 1, 4, 9. I will continue to glance to the right hand side so that we can see, I can see if there's any questions for you. For me, not for you, for me. But also, if you know the answer to a question that you see written in the chat, please answer it, explain to people. That is absolutely fantastic, people interacting with each other, because it's not like a lesson where if people were talking while I was talking, it would be confusing for everyone. Because if you're typing while I'm talking, it's only you missing out on what I'm saying, so it's fine. Okay, so we've now got, remember, an x and a y makes a coordinate. An x and a y, an input and then an output. If you watch Monday, this is all following on from what we said there. So minus 3, 9, put a little cross. Minus 2, 4. Now, have you all spotted what I've done wrong here? This is minus 3 minus 9 and minus 2 minus 4. It's very important we remember that when we plot these, it is minus 3 up 9, minus 2 up 4. There is no negative numbers in the x squared. 1, 0, 0. It won't always go through 0, 0, but this one does. 1, 1, 2, 4, and 3, 9. Now this is the first bit that sometimes gets confusing for people. We must make it into a curve, but in order to do so, when we're doing our curve, it's got to be smooth. So what I do is I start here, and I'm constantly looking at what the next one is going to be, because it's going to make a bowl shape. You have to make the noise, but it does make it more fun. So it's going to be a bowl shape, and you can see the bowl shape. Now, I'm going to do this for every single question we do today. As soon as I finish it, I'm going to draw a dotted line in the middle to show the line of symmetry. There is always a line of... That's not an F, not an S. A line of symmetry in all quadratic graphs. It's to help, and it also helps you, if you can draw the line of symmetry, you can check whether you're doing it right. If I've got my line of symmetry and it does look the same on both sides, it's probably right. So we've just done y equals x squared. No, we haven't, sir. What? Why are you saying no, we haven't? It's because we haven't put the name. Okay. Now, y equals x squared. Now, I'm going to quickly glance at some questions. Eddie, don't worry about being late. Why are the minus numbers not minus squared numbers, not minus ones? It's because if I do minus 3 squared, that is equal to minus 3 times minus 3. And if you think back 6, 7, 8 weeks ago when I was doing negative numbers, when we multiply negative numbers, you get a positive outcome because they undo the negativity of each other. If I lose bad things, I'm happy. I've lost bad things. So minus 3 times minus 3 is plus 9. That's why it disappears. Excellent question though. I'm assuming... I don't know what your question is, Nina. But hopefully Alex's question has just been answered by that. That's why it's always going to be positive. Negative times themselves are going to be positive answers. And that's going to be useful for the next one. So I'm only going to rub out the bits. So this is going to change. And we'll get rid of this bit. And we'll get rid of the actual machine. We're now going to go down to this one. There's 2 ways I can do this. If you like to do it the long way, and that's absolutely fine, because this one will probably make you more likely to get it right, you can write it all out, minus 1, 0, 1, 2, 3, but instead of writing y, you can break it into x squared and plus 5. X squared and plus 5. Now, hopefully you all see. Now, this is why some people get confused. This is why I'm trying to make this very clear. The y will be the outcome of that. Plus 5 doesn't have an x in it. So it's always going to be plus 5. It doesn't matter what x is. X doesn't feature in plus 5. So therefore, it's plus 5, plus 5, all the way along. It's only the x squared, which we've already done. Minus 3 squared is 9, 4, 1. It's useful to learn this pattern. 9, 4, 1, 0, 1, 4, 9. It's the square numbers, forwards and backwards. Okay? Now, to do x squared plus 5, we want to only add the x squared and the 5. So that would be 14, 9, 6, 5. Notice it's a quadratic, so it repeats. So when we were to do this one, 14, 9. Now, this is not what we're learning today's lesson, but it's a nice observation to make by drawing on the same graph. You may have noticed that x squared plus 5 is exactly the same curve as x squared, the green one, just moved up 5. That's an observation for like higher tier GCSE, but it exists, so let's just do it, but unless we write its name, y equals x squared plus 5. And what I'm going to do is I'm now going to delete the green one so you can just focus on what the blue one is saying. And the line of symmetry happens to be the same on this one, so I'm not going to rub that out. But I did say I always have the line of symmetry on there. So, you can see I've done this. Now, I think there's a nicer way to do that. Rather than doing a whole bigger table, and the reason is, I will show you that for the later ones, you can do tables which are like x, you break it into, so let's say I was doing this one, I break it into x squared plus 3x and minus 2, and I will do it like that. However, I think there's an alternative way. And I'm going to do the alternative way with x squared minus 3. So I'm just not doing the same question twice. What you do is you write x squared minus 3 is minus 3 squared minus 3 minus, and obviously in a calculator this is quite quick because you can just change each time. You kind of just substitute them in one at a time and do them either in your head or on your calculator. You don't even need to write these ones out. It's just understanding what's going on in your table, which is at the top. And I'm going to move it up to the table in a minute. 3 squared. Now the reason I've put a bracket in here is because I want to show that the bracket is the substituted number. It's the number I've swapped in for x, because the machine we've changed to minus 3, it's x squared minus 3. X number squared minus 3. X number squared. So when we then do it, x number squared, minus 3 squared is 9, take away 3 is 6. 4, take away 3 is 1. 1, take away 3 is minus 2. 0, take away 3 is minus 3. 1 minus, take away 3 is minus 2. 4, take away 3 is 1. And 9, take away 3 is 6. Notice it repeats. You always know in a quadratic it's going to repeat. So you just want to try and make sure that you've got that repeating pattern. If I rub out the blue line, when you rub things out you always have to go, and we've got minus 3, 6. Where are you, my little pretty? That sounded a bit like an evil Bond villain. Where are you, my little pretty? Minus 1, minus 2, 0, minus 3, 1, minus 2, 2, 1, and 3, 6. We then the line of symmetry stays there. That will change for the next one. I'm just giving you a heads up. So you see the two methods I've got is a big table where you do it all manually, or you just have the table like this one, but you just do each number one at a time by substituting in. Now, because of this, I'm going to do this one using a table. I know you can't see this one. I'm going to do this one using a table, and I'm going to do this one using the substituting method. But hopefully you can see so far I've got a lot on the screen, so let's get in the habit of getting rid of the stuff we don't need. And hopefully we're with me. So I'm going to just check the questions in case there's anyone who's watching live who has questions for me. Because the good thing about a live lesson, I can see if there's anything that's confusing people, they can ask me. So it's absolutely fine that people are understanding. So I'm ignoring the minus signs for the squared. And this is going to be useful, Sophie, to make it clear that the minus signs don't get ignored when we're doing the 3x bit. Let me show you, because that's what we're going to do now. We're going to do this one in green, and because it's we're going to write in the table method. We're going to do x squared, 3x, and minus 2. And the y will be the outcome of all of those three. So hopefully you can see why I've broken it into x squared, 3x, and minus 2. And I have a specific order I do these because I think it makes it useful. The other thing I'm going to do, you will find out that the line of symmetry is going to change on this one. And I'm also going to rub out all of these just to get them out the way. I want the screen nice and clear. So we've got the green ones is this x squared, this is the green one, 3x, x squared plus 3x minus 2. So this is the machine, x squared plus 3x minus 2. You'll notice the input appears twice. So this is the order I do things. X squared, Well, I have said we want to kind of learn these because it's 941 149. 9410 149. So square numbers, always positives. Just like Sophie just said, we always cover the different things. Okay, we always have positive numbers for squares. Then I'm going to do the -2. Do you all agree? Hopefully you do. That there's no x here, so it doesn't matter what x is. It's like we can go. I don't care what x is right now. It's -2, -2, -2, -2, -2, -2, -2. Because there's no x. So it doesn't matter what x is for the -2 bit. The 3x is the bit, and this is the bit, Sophie, I hope you're paying extra attention to this, because the 3 times table, when you've got minus numbers, it is a minus. So 3 times -3 is -9. I'm just pausing there just to give you a chance if there's any questions on anyone clarifying on this, because I did say the x squared there's no negatives at all because there's no negative square numbers, but in 3x there is negative numbers. 3 times -3 is -9. 3 times -2 is -6. 3 times -1 is -3. And then it's 0. 3 times table. 3x means the 3 times table, but we have minus numbers involved. Hope you're all okay with that. And you're all understanding what's going on. If you've got any questions, please continue to ask me. I'm really enjoying the fact that people are asking good questions. So what we now need to do to find out what the output is, remember we've got inputs and outputs. We're going to add those 3 numbers together because the inputs, the thing says x squared plus 3x minus 2. X squared plus 3x minus 2. So 9 take away 9 is nothing. Take away 2 is -2. 4 take away 6 is -2. Take away 2 more is -4. 1 take away 3 is -2. Take away 2 more is -4. 0 and 0 is 0. Take away 2 is -2. 1, 3 is 4. Take away 2 is 2. 4, 6 is 10. Take away 2 is 8. 9 and 9 is 18. Take away 2 is 16. And do you notice there's still a repeating pattern? You've got to expect a repeating pattern, but look what happens when I plot them. -3 goes to -2. -2 goes to -4. -1 also goes to -4. And 0 goes back up to -2. 1 goes to 2. 2 goes to 8. And 3 goes to 16, which technically is about there. We're going to carry on this line. And I did warn you what I always do with quadratics. We're now going to draw in this line of symmetry. There you can see the line of symmetry has moved. The line of symmetry is now in between it's at -1.5. This is really relevant for anyone doing a higher tier GCSE later in your, as you get more advanced, but we're not going to talk about what it means for now. Just note that there's a line of symmetry at -1.5. X equals -1.5. What we're really looking at for here is just can we plot. Remember, today's lesson is about plotting these graphs. Okay, so you can see all I have done is plotted the graph. No, you haven't, sir. What do you mean no, I haven't? You never wrote the name down. If you don't write the name down, you haven't finished it. Squeeze that in there. Oh, it was a minus. Mr. Harris. Don't like mistakes, do we, Mr. Harris? Oh, mistakes will make us learn. Yes, you're right, they do, Mr. Harris. I've reached that point of lack of sleep where I'm even talking to myself. Here we go. That's the long-winded table method. However, I think you'll agree, it'd be quite nice not to have to go and do a whole table. You can do the table, and I'm not trying to tell people which method they should use, because I think it's more important to be accurate than it is to be quick. But you choose which method you like. I am now going to rub out all of the graph we just did, and the light blue example, we're going to use a calculator method or the in your head method, because you're allowed to do these in your head. So the next one we're doing is x squared minus 2x plus 7. But the in your head or the one at a time thing, here's my table. Get rid of all of this now. We're just focusing on the light blue one. And so, I think for minus 3, it's going to be minus 3 squared minus 2 lots of minus 3 plus 7. That's what I would type into a calculator. So you type this into the calculator, and then what you do is you press the up button and change all the minus 3s to minus 2s. Now I believe I can show you this. If I type in fx and I go to here, and no, I want to carry on with my current license, and there's my calculator, and I move it over here. If I type in brackets minus 3 close brackets squared minus 2 brackets minus 3 close brackets plus 7, it will tell me the answer is 22, which is really useful. So that means that tells me the answer is 22. Okay, and the reason it's got quite big is because minus 2 times minus 3 is actually plus 6. Because 2 times 3 is 6, and minus 2 times minus 3 is plus 6. But also minus 9, the minus 3 squared is also plus 9. Remember, we don't have negative square numbers. So that's why we've got 22. But the cool thing about using the calculator for this, if I press the back button, it lets me go and change the numbers in the brackets. So I press delete and change it to a 2. Keep going backwards. Press delete. Change. So all I've done is you kept the same system and pressed equals, and it immediately gives me the next number, the 15. What it's effectively done is it allowed me to change it to this thing just by pressing the change button. So on a calculator, I like this method because you can change it quite quickly. You may find your head is able to do these. I think with the negatives, I like to do it in the calculator, especially when I'm tired because baby's been up all night. But you do what works for you. I think the calculator is quite useful because it can give you all the answers quite quickly. 0 is quite easy because it's 0 squared is nothing. Minus 2 times 0 is nothing, so it's just going to be plus 7. It'll always just be the number bit for 0. It's quite cool. And then I can do these in my head. 1 squared is 1. Take away 2 is minus 1. Add 7 is 8. What am I doing here? 1 squared is 1. Take away 2 is minus 1. Add 7 is 6. I'm predicting the next one will be 7. It could be 6, but we're going to have a prediction of 7. Let's see what happens. 2 squared is 4. Take away 4 is 0. Now, the reason I predicted that is I still hadn't seen a repeat. And remember, the cool thing about this is, as soon as you get a repeat, I don't even need to use a calculator now. I know this is going to be a 10. Because it was 10, 7, 6, 7, as soon as I see that it's a 7 again, I'm going to go, it's going to be a 10. Okay. Sophie, what do you want me to explain again? Alicia, getting a scientific calculator is really useful. Really, really useful. But as soon as... I don't know what Sophie wants explaining again, so I'll wait until Sophie clarifies what it is she wants explaining again. On the calculator, note, I'll do the 3 one. Press the back button. Change the number in the bracket to 3. Change the number in this bracket to a 3. So the bracketed numbers, remember, are the inputs, the x's, and swap it and it gets me 10. So I just you press the back button on the scientific calculators. You press the back button to swap the numbers in, so you can keep doing this using the same formula. Because this formula is effectively, look at the brackets. If you call the bracket x squared, it's x squared minus 2x plus 3. The bracket is like the x. It's like the holding place because x shouldn't be confusing as like, it's algebra. It should be like, it's just a holding thing for a number until we've got one. You could call this whole equation, instead of calling it x squared minus 2x, we could call it question mark squared minus 2 question marks plus 7. Now, what we haven't done yet is plotted the curve. But we've got our table, so let's have a go at it. Now, I don't know if I'm going to fit it all on because it goes to 22. I have to just ignore this number. Because it's too big, we can't fit it on. So I can go minus 2 there. I can go minus 1, 10. I can go 0, 7. I can go 1, 6. And 2, 7. And 3, 10. and effectively 4 would be up there somewhere. So we draw the curve. It doesn't matter that I didn't fit the 22 on, as long as the graph shows everything. I write the name, which was y equals x squared minus 2x plus 7. And I always add in my line of symmetry, which is dooby 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 dooby. That line is called x equals 1. Could you do the table so I can see it visually for the numbers? Absolutely. So let's do this question again visually. Although you can rewind, Sophie, and these calculators are all Casio ones. This one's called an FX 83 or 85 GT. I've got a blue one, which is a Casio FX 88 GT, so it's got the same one but in blue. So Sophie has asked if we can go through the same method here, but using the table, and that's absolutely sensible. I'm going to leave these because these are the numbers we're expecting, and let's see how the table method works. X is going to be minus 3, minus 2, minus 1, 0, 1, 2, 3. The table method breaks everything down, so we break it into x squared, minus 2x, and plus 7. And what we do is we say, start with the x squared. It's always going to be 9, 4, 1, 0, 1, 4, 9. That's standard. The x squared is that. Only time it changes is if we do an advanced one, which we've got one advanced one. This is extension. Don't worry about this one if you're like only year 7 just learning it. But this is for like those people in year 10 and 11 who want to just go, oh, I'd be interested in how that one works. But the next thing I do is the plus 7s. There is no x in plus 7, so it's just plus 7. You can even write the plus 7 if you want. There's no x, so it doesn't matter. It's just plus 7. Then the only thing we've got is the minus 2 times table. Now, those awake among you will realise minus 2 times minus 3 is plus 6. Minus 2 times minus 2 is plus 4. Minus 2 times minus 1 is plus 2. Minus 2 times 0 is 0. So basically, the 2 times table has flipped round because it's minus 2 times table. So it starts with pluses, then it moves into minuses rather than the other way around. We now watch what numbers we get. 9 add 6 is 15. Add 7 is 22. Do you recognise it? It's that one there. So this one we're going to get 4 and 4 is 8. Add 7 is 15. Remember, we're only, Sophie, adding these numbers together because these are the bits that make up x squared minus 2x plus 7. 1 add 2 is 3, add 7 is 10, 7, 6, 7 and 10, which is the same numbers you would have got using the calculator method. Hopefully the calculator method is just build the thing in the calculator. So I've built it using brackets. All I did was built the equation. Let's try and get this so you can just see it. Instead of writing x in a calculator, we write brackets. Minus 2 brackets plus 7. And then inside the brackets we put one of the numbers. So I start it off with minus 3 normally. And then you just keep going back and changing the minus 3 to minus 2, minus 1, change it to a different input. Because the brackets represents the x and the number inside is what number you're putting in. So both methods, go back and watch this all again if you want to. Now I did say that I've got an extension one. The reason for the extension one is just to flag up one emergency detail. And that's why I'm doing this in red. Because whether you're using the table method, the calculator is less likely to have mistakes because the calculator will do it for you and fix it. But it's just in case you're doing one with... that's not what I didn't want to colour that in. If you're doing one with 2x squared, it's more advanced, don't worry. It's okay to be confused by this. I would still get some of these wrong. The plus 6 can stay as plus 6. But this is the only time you do not do 941. And that is because we've got to times it by 2. But lots of people do it wrong. They do 2 times x, then square it. BibMaths tells us we have to square it first. So, what we should be doing, and getting rid of everything that relates to a different question right now, we have to do x squared, then double it. So this one, 2 squared, minus 3 squared is 9, double it is 18. Minus 2 squared is 4, double it is 8. You double it after squaring. Square it, then double. Minus 1 squared is 1, double it is 2. And it turns out I've done so many of these, I've actually learnt it as 18, 8, 2, 0, 2, 8, 18. But remember, I started doing this several years ago. Probably like 25 years ago I started learning this. Ugh, makes me feel old. The minus 5, remember, just be careful, because this is... I've just put an arrow behind my head. That's not helpful. Minus 5x means... It's going to be easier if I rub out this bit and create some space. Or just scroll up a bit. That's not helpful. Minus 5x means we've got minus 5 times whatever the input is. So this one is minus 3. I'm using the brackets to remind you that's the input from the x. That is plus 15. And plus 10, plus 5, 0. And it does have a pattern to it, so it's quite useful in that respect. Then, in order to do the whole thing, we're going to add those three things together. 18 and 15 is 33, add 6 is 39. 8 and 10 is 18, plus 6 is 24. 2 and 5 is 7, plus 6 is 13. 6, 8 take away 3 is 3. 8 plus 6 is 14, minus 10 is... have I made a mistake here? No, I haven't made a mistake here, surely. 8 take away 5 is 3. 8 and 6 is 14, take away 10 is 4. 18 minus 15 is 3. Plus 6 is 9. Now you might be thinking, but there's no repeating here. There is. It's just the repeating happens at 1.5. If I had done this for 0.5 and 1.5, those numbers would have been also 3 and another 4 and 6. So the reason it doesn't look like it repeats, it makes more sense if I draw the line. This is why this is more advanced. Please don't be scared by this. If you've come here and you're in year 7, 6 or 8 and you're like, what? Don't worry. I've deliberately done it from a range of different... You focus on the early ones. There's plenty for you to do here without getting worried because it gets hard. Don't ever be put off because maths gets hard, because the whole point is you start at a certain level. I am not particularly good at golf, but I'm better than I used to be because I had to learn. So minus 113 can be plotted, and 0, 6 can be plotted, and 1, 3 can be plotted, and 2, 4 can be plotted, and 3, 9 can be plotted. And look, if I draw this curve, all it means is that is the bottom bit there. There's your line of symmetry. It's just moved it. That's why it doesn't look like it repeats, but it does repeat once you actually draw it. So that is the whole lesson today. I'm going to check if there's any questions. Yes, you could use the calculator on a computer, Nina. These emulators are free to download, I believe. So you can actually search for Casio emulator and download that for free. Always check with your parents before you download anything on your computers. But if you're using a PC, I use this on my screen because it's just easiest to have. So just download the emulator and you can use a calculator for free, and it's a very good idea. Why does the minus 2 times table start with plus and then go to minus? It's because minus 2 times minus 3 is plus 6. So when you're doing the minus 2 times table, timesing by minuses is where the pluses are, and timesing by pluses is where the minuses are. I strongly recommend, Sophia, doing a lesson on multiplying and dividing by negatives. There is one on my channel. That would really help improve what you're doing. So Alicia, yeah, you were saying you haven't got a calculator like this. You can download this. If you use a PC, you can download this and use it for free. It's got a free trial thing on it. So yeah, there's another alternative. So I hope this has been useful to you. I've got a link in the description for how to practice these questions. So, but Mr. Harris, what does that look like? Well, they look like this because I've got the first one ready. This is the first one. So we're going to. You'll notice they don't get you to do the whole table. They do some of the numbers for you, which I think is lovely. We are going to just do quickly. We've got some numbers already, so let's plot those already. Before you even start, when you do a question like this, feel free to plot some numbers because that kind of gives you an idea of where you're expecting it. 0, 0, 1, and this is like the cheekiest thing. I'm not going to, but I could, if I was doing this question, I could just go, oh, it's probably like this. And I could use that to guess what the numbers are. Don't, but it's a good way of checking your answer. But now I've got these in, I just need to do these ones. So I use the calculator method here. We've got -1 squared plus -1. Calculator tells me that is 0. 1 squared is 1. Take away 1 is 0. The 1 squared, 1 squared plus 1 is 2. You'll notice it all repeats. It's a repeating pattern. And we don't have the repeating pattern here, so we just put this in the calculator. 3 squared plus 3, and that gives us 12. So we can now plot the missing bits. I'll do those in a different colour so you can see that they're the ones that we've added in. -1, 0, 1, 2, and 3, 12. So we then smooth curve it. You will lose marks if you do not draw the curve. You notice this is how many marks are available. 2 marks. 1 for plotting correctly, 1 for making it a smooth curve. And we also write y equals x squared plus x. And because this is what I've been trying to teach you to do, I'm also going to put a line of symmetry in there, just to show that it's got one. So that's how you would do it. That was question 1 from the worksheet in the description. Please do that. I know the temptation is to watch the video and go, oh, I've done maths today, I've done a video. You don't learn in your long-term memory from watching. Long-term memory is what you need practice for. Practice does not make perfect. Practice does make permanent. So you may understand now, practice does not make perfect, practice makes permanent. So if you go away and do these questions, you're more likely to make this learning permanent. If you don't, then the learning I've given you today will go into your short-term memory. And the sad thing about short-term memory is it's limited. As soon as new things happen, like, oh, I was playing Fortnite, or oh, I saw a small chocolate brownie, you will then forget the stuff you learned, and you might as well have not been here. It might make it quicker to learn in future, but if you really want to learn this stuff and make it so it makes sense to you, go away and practice with the sheets that are in the description, because practice makes permanent. Hopefully this has been useful for you today. I will check the questions below. You can always email me. Remember, you can see links to my email. I'm trying to work out where they are. I believe they are there. So you can email, you can get your parents to go on the Facebook page, share things, and remember there's a Taskmaster task this week. Get involved in the Taskmaster task, all of you. I want to see Nina's tray. The Taskmaster task is this. I want to see a photo of a tray with as many things beginning with I on there as possible. But everything must be different. You can't just put 20 ice cubes. You could have ice as one thing, but you have as many different things on that tray beginning with I as you can. Someone is winning at the moment. They've got about 18 to 19 items. I want to see if you can beat that. I tray. It's your I tray challenge. Good luck. I've been Mr. Harris. You haven't. Take care of yourselves. Ciao!